Okay, let's review how we graph logarithmic functions with 6 questions here. Alright, number 1, 2, 3. Match the graph. Match the function with this graph. So let's see. Number 1, base 2. Number 2, base 5. Number 3, base 1/3. Which one look different? 1/3, right? Yeah, less than 1. And other bases are higher than 1. Now let's look at graph A, B, C. Graph A from left to right is decreasing. B, increasing from left to right. C, from left to right is increasing. Which one look different out of 3? A. A is going with number 3, okay? Because base is less than 1, the graph is decreasing, okay? Alright, now let me change the color to orange. Which one goes with the base to 2? So let's see. Okay, we have a point here, 1 and 0, but it goes all the same. So 1 and 0 always passing through on the logarithmic function. So any base, let's say B, okay, with the plug 1 and then you get always 0. It means anything to the 0th power is defined as 1. That is the meaning of this, okay? So this orange color doesn't help a lot. So let me change it. The base is going to be 2. So one ordered pair I can use is log with the base 2 over the 2. What will be the answer? That's right, this will be 1. So this is ordered pair, okay? 2 and 1. Which one has 2 and 1? B or C? Right here, this is 2 comma 1. That means answer is for number 1 is B, like that, okay? This is it. 2 and 1. Likewise, look at question number 2. Base is 5, right? 5. So what is going to be an ordered pair? 5 and 1. That's right. So we have 5 and 1 right there. So this is matching with number 2. So you're using reference points to find the best drawing, okay? And backwards, when you graph it, we are using asymptotes and any reference points on the graph, okay? Now let's graph using parent function, and let's identify the any transformations if it happens, and then we will graph and let's answer domain and range, okay? So this is the preparation for quiz tomorrow. So let's see. Number 4. What is the vertical asymptote? X equals 0. So let's start from drawing vertical asymptote at 0. Question number 5. What is the vertical asymptote? Oh, let's say transformation first. Where does it go? Because of plus 2 inside of the parentheses. Moving left to 2. So what is the vertical asymptote now? X equals -2. So let's graph that vertical asymptote, helping line to draw a curve, okay? So that is vertical asymptote. Number 6, what transformation happened because of -1 after that? Down 1 unit. And because of a negative in front of the parent function, what happened? This is a reflection along x-axis. So this will be upside down. So think about from the parent function, number 4, okay? If I flip this upside down, what happened to the vertical asymptote? Same thing, right? And now let's bring down 1 unit. Bring down the vertical line. Yes, still vertical line, right? So it stays as a parent function, even it's upside down and bring down 1. So vertical asymptote is at x equals 0. So always draw a vertical asymptote and start from there, okay? So question number 4, what is the base? Base is number 3, and give me an ordered pair from it. 3 and 1, right? And another one. 1 and 0. Anything to the 0 power is 1. 3 to the first power is 3, and I'm writing backwards because we switch x and y coordinate in logarithmic function. So let's plot those points. 1 and 0 right here, and 3 and 1, 1, 2, 3 and 1 right there. So this is the parent function. Connect the dots. I want 3 points, but yeah, I have 2 points here. Can I have another point then? How about 1/3? -1 and 1/3? No, not -1. I cannot put, wait a minute. 1/3? Yeah, -1 and 1/3 right there, right? Probably, okay. But that's okay. You have at least 2 points with 1 vertical asymptote. That's a good graph, okay? If you have to find it, you can find another point like that. All right. So, question number 5. What do I need to do? Move the graph left 2 units. So by knowing that this location from that vertical asymptote, and let's do the same way, okay? So this point moved to the left 2 units. It was at 1 and 0, left 2 units. It's now right there. And next point was at 3 and 1. 1, 2, 3, 3 and 1, but I need to move it here. This one left 2 units, so this will be the location. Make sense? So we just translate these points to the left, and then we connect the dots and follow the other end towards that vertical asymptote, and that is a good graph. Now let's see domain and range. What is the domain of this function? Number 4, parent function has domain. X is greater than 0. Range of this function, all real numbers. So make sure you're drawing up and down, going with the arrowheads on the drawing, okay? And when you use TI-84, make sure TI-84 cannot graph all the way down, okay? So it stops somewhere. Number 5, what's the domain? It is moved to the left 2 units, so x is greater than -2. What's the range of this function? All real numbers. Now let's do number 6. So I'm going to copy number 4 first of all, okay? And then I'll do one at a time. Let me use 2 ordered pairs, 1 and 0 and 3 and 1. Okay, that was number 1, first one. Number 4, right? So this is y equals log of x with base 3. That is parent function. And I will show you a sequence of the transformation one at a time. Let me use purple color to flip it. Can we flip this upside down? Reflect this drawing over x-axis? Yeah, let's try. So this point you flip, it stays same, right? The above point goes below. So I need to have this drawing, okay. So this will be y equals negative log of x with base 3. And what do I need to do after that? Down 1, right? So I'm going to move it down 1. So this point goes down 1, and this point goes down 1. And let's move, connect the points. Nice and smooth curve. And then the other end follow along the vertical asymptote. So this is going to be y equals negative log of x with base 3, and then subtract 1. That's how we graph sequence of the transformation here. What's the domain of this function? Same as parent function, x is greater than 0, right? What is range of this function? Same thing, because of the arrowheads at both ends, it goes up and down, so it is all real numbers. So we reviewed how we graph logarithmic functions without a calculator.